Great. Um, Good afternoon, everyone. So this is one of the last between the lunch. So I'm gonna speed it through. So I'm here to present construction program and production control ontology, required integration for construction digital twin. This is coming out of a project, a collaborative project between industry and academia in the UK, where I was part of the project with Dr. Karim Farghaly, who's a lecturer in UCL. So I'm a bit out of my comfort zone too, because he was the one who wrote the paper, and he has the best information, not me, but I'll try my best to convince. So what we have seen is we have a lot of information that's being digitized in different systems from the past 5 years or 6 years, but it's not integrated mostly. What happens here is like we are losing an opportunity to instrument the construction process. So we have the information, but it's all fragmented in different pieces of like software. We cannot actually get insights from it, or we cannot learn from it. So another thing that we have found out is like there's a lack of a common interface to this product and process information. So we do not care if it is distributed among like different databases or something. If we have a common interface to this data, then we could have better learning and better kind of like future automation. How does a construction control room or such an interface in the current world look like? It's like this. So if you go into any construction site, you would see an office similar to this, which has a lean construction kind of boards involved. So it's mostly near a breakout area. So you could come in as a trade contractor, there would be a board for you, and you would start like putting information in it. And this information is in the board, but it's not recorded in any software system, and it gets lost. So there's zero traceability, and the information is again fragmented. And the problem here is like everybody works with their own data, they put it in, they don't put the assumptions, and there's no golden thread of information between these kind of like processes to understand what is happening. So every time what we do is like we create an input, we process it, we create an output from that processing, then we put it out there. Ideally, it should be the input to the next process, but there would be a kind of like process of find, retrieve, store, convert, and restore to actually create it as an input to the next process. And in between, we are losing a lot of information and opportunity to instrument the process. That is why we had this particular project funded by the UK Research and Innovation, Innovate UK, which is set up as a demonstrator project to help UK construction clients and contractor be more efficient and proactive rather than reactive by creating a scalable and repeatable plug-and-play construction management platform. We have our industry partners here, Maze Construction, which most of you might already know, is a global MNC. Mission Room is a visualization platform. They have like large 3D caves. 3D Repo is again a BIM review kind of a software, which could handle all the 3D contents, as well as like the different, what they call as 3D diff, which is kind of like a version control system like GitHub, but for building information models. Then we have AVFile as a partner who was dealing with the data acquisition, automated data updations, etc. And finally, UZL as another partner. So for this project, I was not representing ETH, but I was from Imperial College London. So this is from my past role. What we envision is to have a construction digital twin, basically where people and artificial intelligence, linked data, reality capture, Internet of Things, and maybe robots could actually interact together with this fragmented information in different kind of databases, all integrated through a semantic web kind of a picture. When we started out, we initially found out these kind of things that is required if we need to do construction control. First, the documents and files, that is basically all the documentation that is required for an activity to happen at a construction site. Sorry for this. The second, we need planning and site information. These would be the schedules, 4D building information models, a lots of Excel sheets, and finally, real-time data. And we thought we could integrate it directly, but what we found out is like for a pilot study itself, we had like 20 subcontractors. That means like 20 streams of information, 20 streams of like all of these things coming together to the project manager where the information was being handled. And it was not just the project manager, the hierarchy was like project director, then there were like package managers, which each package with the subcontractors, then the subcontractors. Then there's a lot of like information flow from bottom to up and top to down, and most of the things worked well, but like there were instances when critical things were missed and then the activities were delayed, and a delay in an activity by a day is equivalent to £1 million or something like that in the construction site we were working at. So what we explored was, can semantic web technologies help to integrate this information, which is fragmented, which we believe will remain fragmented. So we are not assuming that everything would come to one place. So there were like at least 3 common data environments in this particular project. So ideally, common data environment is one single source of truth, but it's like 3. There were inconsistencies within the data. They were following 19650, as they say, but still this was occurring. So to create the ontology, we use kind of like a mix of a meta ontology and the scheme kind of an approach. First, we identified the scope, purpose, and intended users of the ontology, specified the requirements of the ontology, reviewed the domain knowledge and existing ontologies, enumerated high-level classes, then constructed the ontology, integrated existing ontologies, and finally evaluated. So I'll just go through the process. So first, we identified the end-user requirements, then what insights they were requiring from this particular data set. Then from that insights, we started looking at different data sets to see which data we required, going on to the integration of the data. And then the last 2 things we wouldn't discuss much in this presentation was predictive analytics. We built analytics engine to predict problems and then visualize it in a control room. So data collection, we were involved in the look-ahead planning meetings. We interviewed the end users. We had access to all the documents and software for extended period. Then we also had like separate meetings with end users involved in this process, and also with problem owners who are the clients and the other people. I apologize for the small text here, but it would not come in the paper. And we also like held different like at least like 6 to 7 workshops on site with all the trade contractors, project directors, package managers, etc. At different stages of development of the ontology and implementation. So the first one, to get the requirements, we observed the look-ahead planning meetings, had semi-structured interviews. Then we came up with a set of requirements based on that. We held discussions with the owners and then had member checks, and then it was a cycle multiple times to get the final end user requirements. And I'm trying to see if it works. So we had around 16 end user requirements. So what we felt from this is like these are very simple to achieve and generally, and the end users really don't know the potential of the data also. So we actually added a bit more of this end user requirements with the ontology when we developed it. Then some of the competency questions we were looking at based on the kind of like project director's requirements. What's the progress of each subcontractor for each deliverable? Where is the subcontractor on a specific date? How many planned data date changes was there, and what were the reasons behind it? So these are the things project managers want to know, but it is there in the data. I'm not saying it's a rocket science, but it's very difficult to find these kind of things in a construction site. I can show you the examples later. Then from there, we looked at how do we think of data integration. So we had the end user requirements and our own data analysis and access to these tools and workflows. From there, we came up with a set of like data integration requirements. Then again, we discussed this with the actual problem owners who are the people at the construction site. We had a feedback kind of a thing, and then we came up with the data integration plan, which is shown over here, which is about like a lot of things. So what data has to be integrated, where it has to come from, etc. So again, the same thing, like we had to map like different kind of like data sets that we have with the requirements that we have, and we came about with kind of like three main things. One is about activities. We need all the activity information, and that activity should have like a document's information. Like so if an activity has to happen now, a document had to be submitted 1 month ago to go through all the checks and stuff. So we had like rules written over it, and each of the document would have a work package. It would be at a zone. So we need not actually create an Excel sheet with everything in every word to get this, but all we need is, if there is an activity, we need to have a work package and a place and a trade contractor. Then it will all find itself. The same for deliveries in the construction site and the delivery schedule. Same for all the documents. Like if a document has a work package and a location and a trade contractor, it will find itself based on the dates that we have. Once we had that, we started developing the ontology, which is rather large. I hope that we can go bit by bit. So as I told, like one of the main part was the location. So we use the bot ontology and the DICE ontology to define the location. So we have the bot site and CPC site, which is together, and we have the geometry. Then at the site there would be the building, then the story, then the kind of space, and then the particular building elements. And for all this, we would have kind of an activity associated with it, and there are like two kind of activity. The production activity is actually the building activity, and the quality activity is mainly about like whether we sign it off after we deliver this, what are the kind of like ideas around that, etc. Then we have the information. So information is like, there's a lot of information that goes into actually do the activity. So that is like pre-construction information, construction information, procurement information, and some other information for daily management. So that also goes through in. So we use, we call it CPC information container, but it's based on ICDD, which is information container for linked data delivery, I guess, if I'm pronouncing it correctly. So that's how we did it. So this particular ontology is kind of like, even though it seems like a large one, it's an integration of bot, DIZ, brick, a little bit of IFCOwl, not a lot, ICDD, DCAT, event ontology, time, friends of friends, and then provenance ontology. So that's how we linked it together. So how many classes have we created? Very less. It's more instantiation of classes for CPC that we have done it. So the idea here is we are not creating another ontology to be put out, but we are trying to show many of the ontologies requirements that we need can actually be built by combining existing ontology. Finally, so this is how it happens in the background. This is how it was displayed to the construction people. So on the left, you have all the submittals, etc. On the middle, you have kind of like I think this whole thing is about the submittals, which goes on to the activities. And here you have the control on the activity, both on the 3D model, the 2D plans, and then the schedules, just like conventional project management. On the rightmost, you have the kind of real-time data on construction sites. This is also required. It's not just a Power BI, it was actually implemented in a construction site. You can see it from the bottom where the rooms and the COVID requirements, etc. Look-at planning meetings were held in this room with this data. And all is not good. Even with this project, when we did that, we had problems with data accessibility, data extraction, that is getting the data out of the subcontractors, mainly because of different types of like submission format, problems with naming consistency, even after following 19650, I would say. Then semantic enrichment, that's like some of the things were not, I mean, we clearly instructed people to put it in a certain format so we could link it up. It didn't happen. There were problems with like collaboration and resilience. Like if one thing goes wrong, everybody goes back to the old format. So we have to start from scratch again. I'm a bit concerned how I could show this slide. Yeah. So if you see here, this is how the submittals were made, like with Excel sheets before. So that is like there was an activity called early walls here. It was submitted as this one, and in the next week they submitted again. It has delayed with the reason over here. It's blurred for a reason because we are not allowed to show it. So they submitted with a reason for it. Again, next week it got delayed, and we were not really figuring out like what is happening or everything at the end. So at that week, you would always have the reason. But at the end of the project, or like 1 month later, when you are looking at the delays, some of these things are in different folders, people cannot find it. What we did is we replaced the same thing, an Excel-based format, into an Airtable for data input. And what happens is like all the delays, the whole thing came out here, and you could click on it to get why there was delay. So this is a simple example to show how these kind of like approaches are helping us really access the information. And this is the first like step in towards a digital twin or AI or whatever it is, to actually have this information in a computer readable format and to do process over it. So coming to the conclusion, what we did is we understood that data integration is necessary for production control, because without the data integration, information is lost in large projects. In small projects, it might not work, but in large projects, it's difficult. We also demonstrated from our project that construction control ontology allows for generating proactive insights basically from this integrated data. And also, last but not the least, there are several challenges when we are thinking of like implementing ontologies in the actual construction industry. So what do you need for a construction production control room? So first, what you might think is like it's just a hardware or space or room, least cost. Then you begin to understand you need visualization. Then you begin to understand you need KPIs and report. And that's where the Power BI kind of like construction control room stops. But if it really wants to make any sense, you need to have like a lot more, which is space room, data integration, KPIs, visualization, data storage, data capture, then proper requirements, and the hardware. And it's going to cost more, but that's where the value is there. Whatever is before that, you wouldn't get much value on the implementation. With that, I conclude my presentation. So I'm Ranjith, now a postdoctoral researcher at ETH, and the first author of the paper, and my colleague, Dr. Karim Farghaly, is a lecturer at the Ballard School of Sustainable Construction at UCL. So if you have any questions, you can contact me or Karim. Thank you.